Hello everyone. In the chapter amines, we'll move on to the preparations of amines. So there are a number of methods are there to prepare amines. So here we'll discuss the method of preparations. So first one by reduction. So reductions mean addition of hydrogen. So here the nitro compound can be reduced into amines here. So this is nitroaniline. So that can be reduced into an nitrobenzene. It is nitrobenzene that can be reduced into aniline. So by treating with the reducing agent tin and HCl. So this is one of the method. Another one is nitrobenzene can be reduced into aniline by treating with iron and HCl. So this is reduction. Oxygen is replaced by hydrogen. Addition of hydrogen is takes place. That is what we call it as reduction. So FeHCl or tin or HCl we can use for a reducing agent. So remember students, we should know the characteristics of the all the reagent, what is the work of that particular reagent. So here FeHCl, so this reagent is more favorable one compared to tin. So that is because ferric chloride, what it forms during the reaction, that can be easily hydrolyzed. So easily hydrolyzed, so that small amount of HCl is sufficient for the reaction. Therefore, if they ask which is more favorable one, iron along with the HCl, that reducing agent is more favorable for the reduction. So that is first one is reduction of nitro compound. The second one, reduction of nitrile. So here, so if we have a nitriles, okay, reduction of nitriles. So if we have a nitriles, so by treating the proper agent, that is nickel with H2 or sodium or mercury with ethanol. So what happens here across the multiple bond? So RC triple bond N is there. So across the multiple bond, what happens? Addition of hydrogen takes place. So here hydrogen and here hydrogen. At that time, shifting of a bond takes place. So you are going to get RCH2 NH2 as a product. Okay, so here across the multiple bond, cleavage takes place or addition of hydrogen takes place. So that is reduction of nitriles. So this one, a reduction of amide. So RCO NH2. So dear student, it is RCO NH2. So in this is what we call it as amide. Generally, we call it as amide here. So by using lithium aluminum hydride followed by hydrolysis, so what happens? Formation of an amine. So this is primary amines is formed. So C double bond O is there. So here what happens? So this oxygen is eliminated, and in that place two hydrogen groups are comes and attached. So that is what we call it as reduction of amide. So if you use lithium aluminum hydride as a reducing agent, it's a strong reducing agent. So what happens here? So here amines are formed as a product. So that is regarding the reduction with the amides. So next one is ammonolysis. So ammonolysis in the sense successive replacement of alkyl group from ammonia. So if we have ammonia here, third one, ammonolysis. So if we have ammonia, when you treat with an alkyl halide, so what happens here? Successive replacement of alkyl group to ammonia takes place by replacing hydrogen. So here you are going to get RNH2. So primary amine is formed. So again, this primary amine, if you treat with another molecule of alkyl halide, again successive replacement takes place, so that we are going to get a secondary amine. So if I again continue this, another molecule of alkyl halide, you are going to get RNH2 N R R. Tertiary amine is formed. Again, if I treating with another molecule of Rx, you are going to get R N R R. Okay, so that is, we call it as plus here and X minus. So quaternary ammonium salt will be formed. Okay, so quaternary ammonium salt will be formed. So in all these cases, if you observe, successive replacement of ammonia by alkyl group is observed. Therefore, this is what we generally call it as ammonolysis. From ammonolysis, one can synthesize primary amine, secondary amine, tertiary amine, and quaternary ammonium salt. So this is a way how to synthesize amines from the process ammonolysis. We will move on to the next method of preparation, that is named reaction, Gabriel thalamide synthesis. So this is one of the very important one. So this method is purely used for the primary preparation of primary aliphatic amine. Remember it, only primary aliphatic amine can be synthesized by using Gabriel thalamide synthesis. So in a Gabriel thalamide synthesis, so first you have to use a thalamide, which on treating with the base potassium hydroxide, potassium salts of thalamide is formed. Okay, see here. So what happens here? Water molecule will be liberated. Okay, so potassium salts of thalamide is formed, which on treating with the alkyl halide, so this KX group will be eliminated and you are going to get N-alkyl thalamide. You are going to get N-alkyl on treating with the base. Okay, which on treating with the base, two molecules of a base you have to treat. So here bond cleavage takes place, and so bond cleavage takes place, and here NaOH will be there, H comes and attached to this place, and ONA is there, so that will comes and attached to the cleaved COO group. So we are going to get a primary amine. So this is one of the very important method of preparation, that is Gabriel thalamide method. This is used only for the preparation of aliphatic amine. So we can't use an aromatic amine here. That is because, so if you use an aromatic halide here, so that will undergo delocalization. So what happens? You can't get the amines over here. You are going to get some other product. Therefore, only pure aliphatic amine, that's a pure, especially a primary amine, can be synthesized by this particular method. So that is regarding Gabriel thalamide synthesis. In this particular topic, you should remember the sequence, how the reaction takes place, and another one, which kind of amine can be synthesized by this particular method. So that is very important one. So next, I'll move on to the next method of preparation, that is Hoffman bromamide degradation. So in a Hoffman bromamide degradation, this is also named a reaction. In Hoffman bromamide degradation, so if we have an acidamide or acid amide treating with the bromine along with the base sodium hydroxide, you are going to get an amines here. Okay, so RCONH2 treating with bromine along with the sodium hydroxide, you are going to get RNH2 along with sodium carbonate, NaBr, and 2H2O. So this is the method where this CO group will be eliminated and you are going to get an amines. So this is a method where we can observe one carbon less in a product compared to the reactant. So always remember here, one carbon less in product compared to reactant. So this is the only method where we can observe one of the carbon is less compared to the product. So here there are two carbon. So when it undergo Hoffman bromide degradation, you are going to get only one carbon, RNH2. So this is the method of preparation. So different method of preparations are there for an amine. So the two, that's a Gabriel thalamide and Hoffman bromamide reaction. So these are the two named reaction in this preparations of amines.